right, we are talking about similar solids again today, and I have to say, I don't recall ever learning this when I was in geometry. Times change, but they did have a question on the SAT about this. Not, I don't know that this year, but on the practice test that I did, and I took almost every SAT practice test this year, this did come up, and it's not that hard, but it's one of those kind of, you know, if you didn't pay attention on the one day this was taught, then that, you know, kind of a...
Like, is it all algebra, like geometry and calculus? Like, is it all the math on the basic or the SAT?
It goes up through pre-caltrig, and so there's quite a bit on there, but it doesn't include calculus. All right, so we want to be able to calculate the scale factor of similar solids today. So similar, we've had that word before. We did similar triangles. Similar solids have exactly the same shape, but not the same size. We've got one big guy, one little guy, one little guy, one big guy. But all they've done is just grown, all right, proportionally, all right? They've been enlarged, like with an enlarging ray or a shrink ray. All right, two solids are similar if the ratio of their corresponding linear measurements, important here, linear measurements are equal. If the ratio of their corresponding linear measurements are equal. Linear measurements, we want to make sure we understand what linear measurements are. They are units to the first power, not units squared, not units cubed, units to the first power. Length, width, height, a slant height would be good. Slant height, radius, diameter, circumference, perimeter. All right, perimeter. All right, these are units to the first power. So if you have units to the first power, that is a linear measurement. Feet, meters, inches. All right, not inches squared, not inches cubed. And so as long as we're comparing linear measurements, we can tell if our solids are going to be similar or not. So for this first set here, determine whether the solids below are similar. So to determine whether they're similar, I need to compare corresponding ratios. So I'm going to start here on number one. Here I'm going to go with my height compared to my little height. All right? So that's going to be 12 over 3, which, what does that reduce to? 4 over 1. So I am going to keep the over 1 part. 4 over 1. All right? And then I have, let's see, I have this sort of measurement here compared to this one here. Those are corresponding. So that's 8 compared to 2. And what does that reduce to? 4 over 1 again. And then I have our length measurement compared to length measurement. So these are corresponding measurements, and that is 20 over 5, and that again reduces to 4 over 1, okay? Are all of their length measurements proportional? Then yes, they are similar. Yes, similar solids. And give the scale factor in simplest form, that would be 4 to 1. You'll notice here, the 4 corresponds with the big figure. It's 4 times bigger than the little guy, all right? So the bigger number corresponds with the bigger figure, and the little number corresponds with the littler size figure. Does that make sense to you? Okay. All right. Let's look at number 2. All right, so again, we want to compare corresponding sides. So what does 6 compare with? 10. All right, so that's 6 over 10. How do we clean that up? Divide by 2. Divide by 2. That becomes 3 over 5. All right, what does 6 compare with? 10. All right, so 6 over 10. What can we do with that? How do we clean it up? Divide by 2. Divide by 2. So that turns into 3 over 5. Oh, it was the same. I'm silly. Oh, man. All right, and then we have our height of 8, which lines up with our height of 12. And again, on those we can divide by 4, top and bottom. 8 divided by 4 is 2, and 12 divided by 4 is 3. Do they match?
No.
No. Are they similar solids? No. All right, not similar. All right. They are not similar solids because these they are not equal. On number 1, everything was equal. On number 2, they were not the same ratios. Okay, any questions on that?
No.
Can we compare, just on number 3, just to get started here, what does 24 compare with?
The diameter 20.
Ah, okay. So there's a couple ways we could do this. We know that this is a diameter of 24, so that means I have to have the diameter of this one as well, which would be 20. Okay, so we would compare 24 to 20. Could you compare the radius length to the radius length? That would also work. So, make sure they match. Make sure they agree. 20 over 24, divide by 4, top and bottom, that would be 6 over 5. All right, and then we have a height of 30 and a height between bases of 25. So that would be 30 over 25, and I'm going to divide top and bottom by 5. So that would be 6 over 5. All right, are these similar? Okay, so yes, they are similar solids. And what's their scale factor? 6 to 5. All right, so because those linear measurements match, they are similar figures. So what's very interesting about similar solids is that if you know their scale factor, then we can also figure out what their volume will be, or what their surface area will be, which is very, very cool, all right? And so it turns out that if 2 solids are similar, with a scale factor of A to B. So those are linear measurements, remember. If we know their linear scale factor, then their volumes and surface area, well, remember, this is units to the first degree. What happens with area units? What do we do with those? They're to the second power. Okay. Well, we have to take this same proportional thing, but we also have to take it to the second power as well. So their surface area is going to be A squared to B squared. All right, they are units squared for area. So it makes sense that our surface area is going to get squared as well. What do you suppose the ratio for volume is? Yeah, A cubed to B cubed. Again, units cubed for volume. So we get to cube our linear scale factors. Does that seem to make sense to you? All right. So when you think about it, it's kind of nice and shouldn't be too hard to sort of remember. So let's look here. Identify the scale factor ratios for each pair of similar solids. So we already know that they are similar solids. So let's see, I want to find the scale factor, which is just the A to B part for linear measurements. So what are our linear measurements on number 4? What can we compare? 10 and 5, sure. So 10 and 5 we can compare. So 10, oh, sorry, I'm going to write it this way. So 10 over 5, and that's going to reduce to 2 over 1. We would divide top and bottom by 5. So that could be 2 to 1 is how I would write that. And you'll notice if you do like a quick check, 6 over 3, 2 to 1, right? 14 over 7, 2 to 1, right? Okay. All right, so then what is the surface area ratio going to be? 4 to 1, yeah, it's going to be 2 squared to 1 squared. And what is 2 squared to 1 squared? 4 to 1. All right. What's the volume ratio going to be? So what's A?
So 2 to the power of 3.
2 to the third power to 1 to the third power. Yeah, so our A and B, the A is 2 and the B is 1. So we have to cube each of those. 2 cubed, what is 2 cubed? 8. Be careful. And then 1 cubed is 1. Okay. Let's try a couple more. All right, on number 5 here, we can compare lots of things. What do you want to compare? 4 to 6, very good. So if I did 4 to 6, that reduces by 2, so we're going to divide by 2, and that gives me 2 over 3. So my scale factor is 2 to 3. How do I get the surface area ratio? Square them. Yep, 2 squared and 3 squared. We square each because it's surface area. So that's units squared, so we square everything. 2 squared is 4, and 3 squared is 9. And then how do we do volume? Cube them. 2 cubed and 3 cubed. What is 2 cubed? 8, and 3 cubed is 27. 3 times 3 is 9, times 3 is 27. Okay. All right, any questions on that? Okay. So, what do you suppose we have to do if they're giving us, what does SA stand for?
Surface area.
Yeah. So how do I'm starting here at the surface area, sort of. Well, let's see. So they are, so we always have to go back to the scale factor first. So we need to figure out what the A and B are. So my surface area ratio is 25 to 4. That doesn't reduce. So the surface area ratio is 25 to 4. Square root. Very good. Yeah. So this is saying that A squared was 25. What number? So it would be what?
Would it be 5 to 2?
5, yes. So a number squared equaled 25, so that number is 5. And what number squared gives you 4? 2. All right. So I'm going to move this over because that wasn't good. So it's saying A squared was 25 and B squared equals 4. So it's asking, hey, what number squared is 25? Well, it's 5. And what number squared is 4? So we can get it a lot of different ways. We could square root, or we can just think about it a little bit. All right. So now that we know that our scale factor, our A is 5 and our B is 2, how do we get the volume ratio? Cube them. So 5 cubed and 2 cubed. 5 cubed is 125, and 2 cubed is 8. Okay. Questions on that? All right. Which one are they giving us a number 7?
Volume. So
volume. They're giving us 160, oh, that reduces? Holy mackerel. Never would have thunk it. 162 over 384. Ooh, I'm going to check to see. 162 divided by 384, and I'm going to math frac that, and it is 27 over 64. 27 over 64. So that's a good idea. Check to see if it reduces. All right. Now, it reduces. Our volume ratio is 27 to 64. What is that telling me? That is A cubed. A cubed is 27. B cubed is 64. And what can I do? Cube root. Very good. You could cube root if you're unsure. That's under the math menu on your calculator if you don't know, because we don't do cube roots very often, but we could do a cube root of both sides here. So in the math menu, let me turn the screen brightness here. All right. On the math menu, right there, all right, there is a cube root. That's item number 4 under the math menu. So right there. Cube root of 64 is 4. All right. So what's the cube root of 27? 3. All right. So it turns out that our A is 3 and our B is going to be 4. All right. How do we get the surface area?
Power of 2, so that would be like 960.
Good. So 3 squared and 4 squared, 9 and 16. Very good. All right, questions on that? All right, how long has it been? 17 minutes? Okay, awesome. Let's look at number 9. Number 9. Solid A is similar to solid B. The ratio of the height of solid A to the height of solid B is 7 to 3. What information did they just tell us? Our scale factor, yeah. So A to B is 7 to 3. So that's our A and our B. We want to find the ratio of the volume of solid A to the volume of solid B. So what do we need to do? Cube them. Yeah, volume is A cubed to B cubed. What is 7 cubed? It's my favorite one. 343. What two numbers add to be 7? 3 and 4. 3, 4 cubed. 3, 4, 3. Okay, there you go. Did you get it? Did you get what I did? All right. This is what I think about. Yeah? 3 and 4 cubed. 3, 4, 3. Yeah. Okay. All right. What is 3 cubed? 27. 3, yeah. All right. So there we go. That's what we need. Cone A is similar to cone B. Very important that we know that they're similar. If the ratio of the surface area of cone A to cone B is 16 to 1, what information are they giving us? All right. So how does that relate for us? Okay, we need to go back to scale factor. Okay, so what does the 16 to 1 represent? Cubed? Squared. Yes. A squared and B squared. They gave us the area, so they're giving us our scale factor squared. All right, which means what's our A? Yes. How do I know that? Square root. So A to B would be 4 to 1. So we definitely always want to find that scale factor first. You can think about it. A squared equals 16. Maybe we need to square root both sides to get the A. All right. Find the ratio of the radius to cone A radius of cone A to cone B. What's the ratio of the radius? Do I need to do anything else, or am I done? What is a radius measurement?
How much is diameter?
True.
It's a linear.
It is a linear measurement. So it is a linear measurement. That is a to the first power and b to the first power. And so that's all we need to know. It is a linear measurement, so to the first power, versus area is squared, volume is cubed. All right. Number 11, cylinder A and cylinder B are similar. If cylinder A has a diameter, what kind of measurement is diameter?
Unit 1.
A unit to the first power?
Scale factor.
That's going to give us our scale factor A and B. Diameter 24, and B has a diameter of 30. Now, I know that those actually reduce. So 24 over 30, I can divide both of those by 6, and that gives me 4 over 5. Those were linear measurements, so my A to B is 4 to 5. And it wants to know, what is the ratio of the volume? What do we need to do? Cube them. A cubed to B cubed. That would be, what is 4 cubed? Yes, it is. Thank you. And then 5 cubed is 125. Okay, do you have questions for me? Is that all right? No worksheet today.